using the proper terminology for things we've already done to date. We've actually come across factors and multiples quite a bit when we were doing fractions, when we were looking for simplifying fractions, when we were looking for common denominators. Okay, so a lot of what we've done today, we've done in the past, but I need to give you the formal words that we use for what we were doing in those early weeks. Okay. So today we're going to look at factors and multiples and the various types of factors and multiples, and then we're going to talk about squares, cubes and their roots. When we've done that, tomorrow we're going to look at index notation and index laws for multiplication and so on. Right, let's start with some maths then. So our smart recap is 3 questions. Evaluate a cubed when a is 2. What is a quarter plus 2/5? And solve 6r equals 30. Let's have a look then. So, a cubed when a is 2. So what's it asking me to do there? What are the 2 things it's involved? 2 times 2. Good. So first of all I'm swapping the letter a for the number 2, and 2 cubed means 2 times 2 times 2. So we've come across this before. 2 2s are 4, 4 2s. Hopefully you've all got 8. Yeah? Number of people and assignments I mark, 2 cubed is now 6 because they're multiplying 2 by 3. That's not what that 3 means. Keep that in your head. That's what we're doing today, cubed numbers. What is a quarter plus 2/5? What's the first thing I need to do? Good. Find a common denominator. Because quarters and fifths don't go together, you can't add them. Good. So you've got to have a common denominator of 20 for both of them. Okay? So to work out what 1/4 is in 20ths, good, by 5. So I do the same to the numerator. So 5 over 20 is absolutely the same fraction as a quarter. Yeah? And then if I do the 2/5, how many times does 5 go into 20? 4 times. Do the same to the 2, multiply it by 4. I end up with 8 over 20. So I end up with 13 over 20 is mine. Yeah? Nobody made the major misconception with fractions. 2 and 1 is 3, 4 and 5 is 9. It's not 3 9s. Okay? That's the major misconception with fractions. Hopefully we're over that. Final one, 6r equals 30. One step equation.
So divided by 6.
Good. So we're dividing both sides by 6 to get r on its own equals 5. Everyone happy? Good. So hopefully your brains are now tuned into a bit of maths. So let's start with the first thing of the day. Okay. What's a factor in maths, in life, anywhere?
What goes into the number?
Good. Everyone hear that? It's what goes into a number. It has to go in a whole amount of times, okay? So a factor is a positive whole number that divides exactly into another number. So when you look at the factors for 16, what numbers go into 16? 4 goes into 16. 4 times 4 is 16. 2 goes into 16. And 1 goes into 16. So if they give you a question and say circle the factors of 16 and list the numbers, you know those numbers have to go into 16. This thing called a factor is sometimes called a divisor. Never seen it in an exam paper, but it is in the curriculum. So just keep an eye on that word divisor. It's another word for a factor. Okay, so let's look at our number 16 that we've just done. We looked at some of the factors that we know from 16, but how do I track every single factor of 16? How do I make our process for doing that then is, let's say we have what are all of the factors for the number 24. You start off with 1, because you know 1 times 24 is 24. Then try 2. 2 goes into 24, must do, it's even. 2 24s. Does 3 go into 24? Yes. Times 8. Does 4 go into 24? Yes. Times 6. Does 5 go into 24? No. And I can stop because I know that if 6 goes into 24, I'm just repeating what I've written there. So you don't have to do very many of those steps to work out all the factors for a number. Okay? And if you do it in a logical way, what people tend to do is just write them in a straight line. And they forget that factors are paired. So what you'll end up with is what people will write 1, 2, 3, 12, 24. And they'll forget about one or other of the factors. Okay? So make sure you do it in a logical manner. So 2 for you to do. What are all the factors for 40 and 64? So what are the factors of 40 and 64? What are factors of 40? What's my starting point?
1 times 4.
Good. And then next one?
2 times
Two 20s. Next.
4 times 10. 5 times 8. That's all I've got to say.
Yeah. So if you do 6, it doesn't go into 40. You do 7, it doesn't go into 40. And stop. This is you back to 8. You're repeating again. Good. Let's have a look at 64 then. I'll start you off. 1 and 64.
2.
2 and
13.
good.
4 times
Good. Lasmith. 4, 16. 5.
8 times do you remember?
8.
5.
8 times tables. 8 8s are 64. So the factors of 64, 1, 2, 4, 8, 16, 32, 64. Happy?
Yeah.
There's something called a common factor. Well, we know what a factor is. It's a number that goes into another one. But what does the common factor mean?
Oh, it's the...
More.
Sorry?
It was like the more.
Good. You use a common factor when you have more than one number. So if I've got, let's say, 12 and 16, and I want to find the common factors, I need to write down all the factors of 12, which are 1 and 12, 2 and 6, 3 and 4, and all the factors of 16, 1 and 16, 2 and 8, and 4. So the common factors are 1, because they've both got 1, 2, and 4. So when it asks for the common factors, it's asking for all of the factors that they have in common. Okay? So it's more than one number. Which brings us on to highest common factor. Okay? So we know what the common factor is. What do we think the highest common factor is?
highest number.
The highest of the numbers that are common. So when we have our 12 and 16 again, yeah, we had 1, 2 and 4 that were common, but the highest common factor that they have is the number 4. Can you see that? Yeah? A word of warning. In the exam, they won't use the words highest common factor. They will use HCF, the abbreviation. Okay? It will just say, what is the HCF for this, that and the other. So it's one of those really important abbreviations in maths in order to answer the question. 1, you need to know what it stands for, highest common factor. 2, what does it mean? It means the biggest number that they have in common that are factors. Okay? Happy with that? Saying yes, let's try one. Okay? So what's the highest common factor, the HCF, of 18 and 30? Big hint for you on this one. I've put the number of dashes is the number of factors there are. So it was a little hint for me so I didn't miss anything. Okay, let's go through it then. This is what are the factors of 18 then.
1, 2, 3.
Where would I start? 1 and 18. 2 and 9. Do the pairs and then you don't miss anything. 3 and 6. So they're all the factors. Let's look at 30 then. Start with
2, then 3. 6.
excellent. So when I look at all of those, which is the biggest number they have in common?
6.
Everyone happy with that? So the highest common factor is 6. Is that what you got? Come on. Yeah? So quite easy. You just write out all the factors, you look at your 2 lists and you pick the biggest number that they have in common. Superb. Where do we use highest common factors? You can use them to simplify fractions. So we did 12 and 16 a minute ago. We said the highest common factor was 4. So if we divide them by 4, we know 4 goes into both of them. It means that I can simplify it in one go, rather than dividing by 2 and then dividing by 2 again. We just done 18 and 30 and we said the highest common factor from that last slide was 6. So if I divide them by 6, I get 3 over 5. So what it allows me to do is simplify fractions in one go, rather than dividing by 2, dividing by 3, dividing by 2, whatever. Good. Good. That's part of it. So it's any number that is only divisible by itself from 1. So the proper definition for a prime number, I'll put it up in a sec, is any prime number is a positive number only divisible by itself from 1, but not including the number 1. So what's the first prime number?
2.
2. Next?
3.
3.
7.
7.
10. No, 11.
11. 13.
That's it.
No, what was that? 19
16.
17.
19.
19.
23.
23.
29.
29.
31.
Yes.
You need to remember the prime numbers up to
97.
30. Prime numbers come up in every exam paper. You cannot escape the prime numbers. 1, they're useful for fractions, for when you're simplifying. 2, they ask you very specifically for questions to do with factors and multiples on prime numbers. Okay, so you've got to remember the prime numbers up to 30, what they are. If they're giving you a nice easy prime number question, it will say circle the prime numbers in a list, like this one does. Okay?
7, 9.
3, 7,
9.
not 9, 9 is divisible by 3.
Oh, yeah.
3 3s are 9.
13.
13. So that's 2 marks just for remembering prime numbers. Where do we use them? Well, we use them in week 2. When we did fractions as a group, we were sick of the term, it's a prime number. Doesn't go into this, so I don't simplify anymore. Yeah, remember when we did that all the way back? 29, it's a prime number. It doesn't go into 50, I can't simplify anymore. So prime numbers are really useful when you're looking at simplifying fractions. There's something called a prime factor. I know what a factor is, and I know what a prime number is. So what do we think a prime factor is? The prime numbers that make up the main number we're looking at. So let's have a look at an example. So any number can be broken down into prime factors. In other words, the prime numbers that when you multiply them together give you your original number. So what we did earlier with 16, we're going to do here with 12. I'm glad you used the tree method because this is what I use, okay? So if we start off with our number 12, what 2 numbers multiplied together give me 12? Well, 2 times 6 gives me 12. I know 2 is a prime number, so I can circle it, and I finished doing that branch of the tree. 6 isn't a prime number, I know it's 2 times 3. So 2 is a prime number, I circle it, 3 is a prime number. So the prime factors that make up 12 are 2 times 2 times 3. So that when I do the multiplication, 2 times 2 is 4, 4 times 3 is 12. So any number can be broken down into a series of prime numbers. Okay? Anybody use the ladder method at school? No? There is another method they teach at school called the ladder method, where you start off with your number 12 and you ask yourself, what can I divide by 12? 2 goes into 12 6 times. Oops. 6 times. Okay? What goes into 6? Well, I know 2 divides into 6 3 times. What divides into 3? 3 divides into 3. Gives me to 1. So my prime factors are 2, 2 and 3. Just like the last method, but it's with a ladder.
It's slower.
Slower.
Yeah.
Okay? You can use whichever method you like. I want you to use whatever method you like to tell me the prime factors of 700. And it doesn't matter how you do it, you will all get the same answer. So start off, what 2 numbers, when I multiply them together, are going to give me 700. That's your starting point. Some people decided, oh, I'll divide it by 2, and ended up with 2, which is a prime number. Good. And 350. And then, being smarties, said, oh, I'll divide it by 2. So you ended up with 2 and 175. And then you started thinking, oh God, the maths has got a bit difficult now. What do I do now? Well, if anything ends in 5, it must be divisible by 5. So you've got a bit of hard sums to do.
75 points.
It doesn't. It's not a point. How many times does 5 go into 1? It doesn't. How many times does 5 go into 17? 3 times. Remainder.
Oh, 17. All right.
3 times. Remainder.
35.
2. How many times does 5 go into 25? 5. So 35 and 5. 5 is a prime number. 35. What 2 numbers multiplied together give me 35? 5 and 7. It's all about your times tables. Right, just to show you it works for any number, give me any number between 50 and 100. 99.
Oh,
What two
yeah.
numbers multiplied together give you 99? 11 and 9. What two numbers? Prime number is 11. What two numbers? 3 and... So the prime numbers for... So smaller numbers can have more prime factors than a big number.
No.
Yeah? So 3, 3 and 11. There you go. What are the prime factors of 72? 72. What should we go for?
2.
I don't like 2.
4.
4 and...
18.
Good. 4 goes in 18 times. What are the factors of 4? 2 and 2. What are the factors of 18?
9.
2 and 9. Factors of 9? 3 and 3. So those who did the Tyrese two-step will have the same answer. 2, 2, 2, 3 and 3. Yeah? Everyone get that? If you do the little circles, it means it's the end of the tree, and then you won't get any more. And when you come to write it out, when they say write them down, it's 2 times 2 times 2 times 3 times 3. So the reason we do this is because when I multiply 2 by 2, I get 4. 4 2s are 8. 8 3s are 24. 24 times 3, 72. Okay? So they make the number you're looking at. So you can actually check whether you've got the right answer by doing the multiplication. Good. So that's factors. Let's park factors over this side of the room. And let's deal with multiples. What's a multiple? What are the multiples of? Times it. Good. Multiples multiply. That's what I was trying to allude to. It's almost the same word. So if you can remember, put it on the top of your head, multiples multiply. When you talk about multiples, we're talking about your times tables. So what are the multiples of 6 on this list? 6, 12. 36, 6 sixes. How do you know 102 is? The reason they put 102 here, one is to find out if you know what a multiple is. 2 is for you to do some long division. So if I told you at the start of the lesson you need to know your times table up to your 12 times table. So 6 12s is 72, so that allowed us to discount this one. To check if 102 is a multiple, what do I have to do to it with 6? Good. So when you do long division, so this in theory is a check of long division, 6 into 10 goes once, remainder 4. 6 into 42 goes 7 times. So really what they're checking here is can you do long division, not be really good at guessing. Okay? Right. So we know what a multiple is. What do we think the lowest common multiple is? Good. So you've got two numbers. You're going to write out all the multiples of those numbers, and you're looking for the first one, the lowest one, that they have in common. In the exam, they won't waste ink and write in longhand, lowest common multiple. They will just write 3 letters, LCM. So don't let the letters LCM fool you. Just remember the M is for multiple. So let's look at a lowest common multiple. What is the lowest common multiple of 3 and 4? All you need to remember, multiples multiply.
12.
So write out, yeah, I've done all the hard work, don't just jump in and grab the glory. Right? So my multiples of 3 are 3, 6, 9, 12, 15 and 18. My multiples of 4, 4, 8, 12, 16 and 20. Don't have to go very far, remember it's unit 2. They're not going to ask you for the 56th multiple of something. Okay? So just go down your list and spot which is the first one they have in common. Tyrese stole my thunder. It is the number 12. Okay? So to find out a lowest common multiple, write out the multiples of the numbers and then find the first one they have in common. So, where do we use them? Well, we use them in fractions. Yeah? When I say I've got 3/5 and I want to take away 1/3, can I do that? You need to find a common denominator. So what's the first common number they have? 15. So you've kind of been doing it already, yeah? When we were doing fractions, you just didn't realise you were doing it. Right. So these are the sort of questions. When they're looking for lowest common multiple questions, if it's one of the harder ones that come later in the paper, rather than just saying what is the LCM of 4 and 5, they will give you a little question that says something about flashing lights or something happening every so often, like gym membership. Okay? A beacon flashes every 3 seconds. Another beacon flashes every 5 seconds. So you've got this one going every 3 and this one going every 5. Okay, different times. How often do they flash together? Right, so if they start off together, this one's going every 3 seconds. 3, 6, 9, 12. This one's going every 5, 5, 10, 15. So the first number that they share in common is every 15. So every 15 seconds, the two lights flash at the same time. Okay? Yeah? How else can they ask these questions? So just to give you another example, because they're really keen on these style of questions for multiples, is something, for example, that has different time scales. So Dave goes to the gym every 5 days, John goes every 6 days, and Katie goes every 15 days. They all went to the gym today. When are they going to meet again? Well, it's a multiples question. The alarm bells ring, so I've got different time scales. So Dave is every 5 days, 5, 10, 15. John every 6, 6, 12, 18. Katie every 15, 15, 30, 45, and so on. Don't have to go on forever. Okay? And before you know it, the first number you come to that they all have in common again is 30. So every 30 days, they meet at the gym at the same time. Does that make sense? Yeah? Okay, just to show you multiple and factor questions from previous papers. So in Unit 2 on November 2010, 5A, write down a multiple of 6 that's greater than 20 and write down a factor of 20 that's less than 6. So a multiple of 6 greater than 20, 6 times tables, 24. Everyone goes to 24 today. Write down a factor that is less than 6 of 20. 2. Yeah? 2 or 1 or 4 or 5, any of those will get you the mark. Okay? So factors are tiny or really small. Multiples usually larger than individual numbers, possibly larger but never ever smaller. The best way to remember it is factors go into things, multiples multiply. So that's objective number 1. Let's do the last bit for today then. Square numbers, cube numbers. So what's a square number? Because they'll have a list of numbers, 3, 5, 25, and they'll say, circle the square number, and everyone goes, oh, 5, because 5 squared is 25. The square number is the result of a number being squared. That is not a square number, that is not a square number.
1 times 1, 2 times 2, 4.
Okay? You need to know the square numbers up to 12 squared. And the sooner you make that association, the easier the next bit on square roots are, because it's the opposite process. So if you can remember or spot 64 as a square number or 81 as a square number, you know that the square root is the other way round. Okay? Square numbers quite literally mean making a square out of numbers. So when we talk about 4 squared, I'm talking about a square that is 4 by 4. And when you multiply it, the area is 16. Okay? So a square number represents an area. How's it written? Well, it's the power of 2 or an index of 2. So you have a base number of 4. That's the number that's being multiplied by itself. And this tells you you do that twice. So it's 4 times 4 is 16. Right. I'm going to give you a really important word of warning now. What happens when I square minus 4? What does it mean longhand? It's minus 4 times minus 4. It's positive 16. Remember that, because when we come to do square roots in 10 minutes, you will have forgotten that. Okay? So if you have a negative number and you square it, so if you've got a minus number and you're multiplying it by a minus number, a negative times a negative is a positive. So it becomes positive 16. Okay. So we need to be able to identify square numbers. So in my list of numbers here, which are my square numbers? 4, 9, 64, 36, 49. I think. What's 1 squared? What's 1 times 1?
1, 2 times 6.
Everybody forgets about the 1. 1 is a square number, because 1 times 1 is 1. And on your list, there'll always be a 1. And nobody circles it, because they don't realise that 1 is a square number. Okay? So keep that in mind. Okay? Good. What's the cube number then?
2 times 2 times 2.
It's the result of that.
James has got it. It's the result of 2 times 2 times 2. So you're right, that is cubing a number, but a cube number is the result of multiplying a number by itself 3 times. Again, they'll give you a list of numbers and they'll say 3, 27, blah, blah, blah. Circle the cube number. Everyone goes, 3. It's not a cube number. The cube number is the result of multiplying 3 by itself 3 times. Cubed is quite literally what it says. It makes a cube. It's the 3 dimensions of a cube. So it's 3 times 3 times 3. For GCSE Unit 2 Maths exam, you need to remember 6 cube numbers. 1 cubed, 2 cubed, 3, 4, 5 and 10. They're the only cube numbers they will test you on. If they test you on 6 cubed, it means they want you to do some long multiplications. Okay? But 1 to 5, if you can remember them, it will help you going the other way when you do cubed roots. Okay? So, cube numbers have a power of 3, as Lasman said quite correctly, and it means 4 to the power 3 means 4 multiplied by itself 3 times. So 4 times 4 is 16, times 4 is 64. What happens when I cube minus 4? Let's look at it. I know that 4 times 4 is 16, times 4 is 64. There's no doubt with what the number is. But what's the sign? Negative. Why is it negative, Jen?
Because they cancel out at the beginning.
Yeah, so negative and negative is a positive. A positive and a negative is a So when you cube a negative number, it gives you a negative result. Okay? Good. Right. Like I said, you have to identify the cube numbers of 1 to 5 and the cube of 10. So which ones are cube numbers here? 1. 27. 64. 125. That's it.
Yeah, 2 times 2 times 2, 8. Sure.
5 cubed, okay? So you need to remember these cubed numbers, okay? 1 cubed, 2 cubed, 3 cubed, 4 cubed and 5 cubed by recognition. Because when you see 125 or 64 on the exam paper, alarm bells start ringing. They're going to ask me about cubed numbers, okay? So let's do the opposite now. So we've done square numbers and cube numbers. Let's do the square root. So what's the square root? The definition of a square root. So what James is saying is, when you have a square number, what are the 2 numbers that were multiplied together that gave me that? Okay, what was the number that was multiplied by itself? So the square root is what is the number that gave me the square number. This is why you need to recognise them in Unit 2. They can't ask you nasty numbers because you haven't got a calculator. So if you can recognise that 16 is a square number and it's the result of 4 times 4, the square root of 16 is the number 4. Okay? So the square root symbol is this. Square root of 16 is 4. Now, 10 minutes ago, we said that what was the square of minus 4? What happens to minus 4 when I square it? Good. So how do I know that the square root of positive 16 didn't come from my minus 4? You don't.
Oh, you get them marked down if you don't put the minus, sorry.
The minus as well as the plus.
Yeah.
So whenever you're giving the square root of a positive number, so if it says to you, what is the square root of 16, and you're all smug and happy and you say, ooh, it's 4, you've lost the mark. Because for every positive square root, there's also a negative that could make it up. So don't forget, minus 4 times minus 4 gave us positive 16. So the square root of 16 is either 4 or minus 4. So every positive square root has 2 options. Good. So we need to recognise number association again. So we're going back the way. So if you can remember the square numbers, you can remember where they came from, the roots. So what's the square root of 1? 1, 2, 4, 9, 11, So that's why you need to know your 12 times tables. Okay? Because it's number association. If you can remember this, you can remember that. If you can remember this, you can remember that. You can come back the other way. Okay? That's why it's important to remember your square numbers. Cubed root. Don't worry, nearly finished. I'm trying to stay awake for that last 10 minutes. Okay? Cubed root. What's a cubed root?
The three numbers that comes to it.
Good. So it's the number that gives you the cubed number. Okay? So, for example, 125, the cube root of 125 is the number 5, because I know the other way round, 5 times 5 times 5 is 125. You've got to commit them to memory. Okay? Cubed root looks like this. They can say what is the cubed root of something in words, or they can use the square root sign but with the number 3 on it. So if they say the cubed root of 125, what is it? Because you've committed it to memory, you know it's 5. Okay? There's no easy way of working it out. You've got to commit it to memory, especially when you haven't got a calculator. Can it be minus 5? No, because minus 5 times minus 5 times minus 5 would have given us a minus 125. Okay? Good. So, you need to know the cube roots of numbers. It's, again, committed to memory. Cube root of 1, cube root of 8,
2,
cube root of 27, 64. Yeah, they're the ones you've got to remember, these number pairs. Try and remember those. So there's a list of numbers. The sort of question you get in exam early on: what's the multiple, what's the factor, what's a third of 69, what's the cube number? So, multiple of 8. Which one's the multiple of 8? 16? Yeah, multiples multiply. So 8, 16, there's 16. Which one's a factor of 30?
10.
Yeah, 10 goes into 30.
You do.
A third of 69.
You do around 1/3 of 69.
Yeah.
69 divided by 3.
Good, divided by 3, so
Times 1.
23. Yeah. And then the cube number. Which of those is our cube number?
27.
Everyone spot 27 in the list. Yeah. So that's the objectives for today. So a lot of what we've done in the past. Multiples, factors, square numbers, cube numbers, square roots, cube roots. Okay? Okay. What we're going to do today is something we've already covered, index notation. And then the final thing we'll do is we're going to look at 6 of the basic index laws. So, an index. What's an index? What did we say that was?
A power.
Good, a power. So an index is a power. We've been calling them powers up to now. Where have we come across indices before? Remember that one? It is the rule of mathematics. If you're going to remember anything from this course, it's big maths. Because big maths tells you the order to do things in mathematics. The I in big maths is an index, a power. They come before addition, subtraction, multiplication and division, but after brackets. So how do indices work? Well, you end up with a base number, and the base number is the number that is multiplying itself. The index tells you how many times. So 2 to the power 4 means 2 times 2 times 2 times 2 times 2. In other words, 2 multiplied by itself 4 times. Okay? When we do it, we actually do the mathematics, we get 16. 2 2s are 4, 4 2s are 8, 8 2s are 16, lo and behold, 16. Okay? So whenever you're looking at indices, like 2 squared, it's 2 times 2. 2 cubed, 2 times 2 times 2. Not, as a lot of people are still doing in their assignments, that is not 2 times 3, which is 6. So, this is the sort of question they could ask in the exam. Calculate the following. So I want you to do 2 things for me. I want you to write it out in longhand. So what does 3 to the 5 mean? And then I want you to actually do that calculation. Right, let's look at the first one. What does 3 to the power 5 mean?
3 times 3 times 3 times 3 times 3 equals what should the index?
Okay, 3 times 3 times 3 times 3 times 3. So we have to do the maths for that sometimes. So 3 3s are 9, 3 9s are 27. So that's our 3 cubed. 3 27s, 81, and then 3 81s, 243. Yes. Okay? You have to have a method for doing the big sum. So if you've got 81 times 3, 3 1s are 3, 3 8s are 24. some kind of method for doing the long multiplications. Next one, 10 to the 4 means so what do I end up with? 10,000. Everyone happy with that?
Yeah.
How do I end up with 10,000? Well, it tells me how many zeros. It's a 1 with 4 zeros. Or, if you want to do the maths, 10 times 10 is 100. 100 times 10 is 1,000. And 1,000 times 10 is 10,000. Okay? So, when you get tens with a power, to know how many zeros they've got, the index tells you how many zeros. So 10 to the 4 says it's a 1 with 4 zeros. 10 to the 8 would be a 1 with 8 zeros. Okay? 6 to the power 3 is
423.
6 sixes, 36 times 6. 6 sixes, 36. 6 threes, 18, plus the 3. Basic. So can you see how it takes you back to week 1? Yeah? All we've done there on indices, week 11, is shot back 11 weeks to doing some basic multiplication. So can you see how you're always going back to the basics? You can't escape them. Good. Index form. We know what index form means. What's the index form? Powers. So when we had our prime factors of 64, we had 2 to the power 6 because it was easier to write 2 to the 6th than 2 times 2 times 2 times 2. Okay? That's what it allows us to do. They're also known as index notation. And whenever you get those questions on prime factors and you end up with lots of 2s and 3s and 5s and 7s, they like you to tidy it up. Okay? So yesterday, one of the questions that we did in the class was, what are the prime factors of 700? And we put a big number up there, but we actually worked out it didn't take too many prime factors to get there. It was actually 2 times 2, which is 4, times 5, which is 20, times 5, which is 100, times 7. So the prime factors of 700 that we worked out yesterday were 2, 2, 5, 5, and 7. 99 times out of 100, when they give you a prime factor question in the unit, they will then go on and say to you, and write it down in index form, or use index notation. What that says is tidy it up for me. I don't like it because it's too long. So if you've got 2 2s, it's 2 squared. If you've got 2 5s, it's 5 squared. If you've got 1 7, it's just times 7. So index notation is basically gathering all your 2s together, gather all your 3s together, gather all your 5s together, and put the index there depending on how many you have for each. So, these are actually considered hard questions in the exam. Question 14 of this particular exam paper, almost guarantee you're going to get a prime factor question that then says, give your answer in index form. Almost guaranteed, okay? So, try writing 48 as the product of prime factors, and then, once you've broken it down, write it in index form. See what you get. So, we're starting off with 48. So, what shall I break that down as?
2 is 24.
2 and 24. Everyone see how we get that. So the two numbers that multiply together that give me 48 are 2 times 24. What two numbers will break down now?
2 and 12.
2 and 12, good.
2 and 6.
2 and
6.
6. And then finally,
2 and 3.
2 and 3. So I've got 2 times 2 times 2 times 2 times 3. So I've got 4 2s and a 3. So index form is what they're after.
2 to the power of 4 times 3.
Everyone get that? Yeah? And that's how it works. So a number can be broken down into prime factors. The prime factors can be written in index form to tidy it up. Okay? Good stuff. And that was index form. Done and dusted. Another one done. Momentous moment. The very last learning outcome for Unit 2. Here we go. Scary stuff. I need to teach you the index laws. Okay? There are 6 of them that you're going to have to get your head around. So let's have a look at the first before we do all of them. So there are 6 rules that you need for, you need to learn them really. The first 3 are the difficult ones, so we'll take our time with those and then we'll take a break and then we'll do the second 3. So the first one is to do with multiplying indices. The second one is dividing them. The third, raising them to a power. Fourth is when you have an index to the power 1, to the power 0, and then finally number 6, 1 to a power. So the first one, in order to be able to multiply 2 numbers that have an index, the base number, in other words 2, has to be the same. What I'm teaching you now does not work if I had 2 to the power 3 times 3 to the power 2. I can do nothing with that because they've got different base numbers. I've got a 2 and a 3. You can't do anything. The only time these rules work are when the base numbers are the same. So in my first example, 2 squared times 2 cubed is the same as in longhand. In green, 2 squared is 2 times 2, and in purple, 2 times 2 times 2 is 2 cubed. If you've got them all together in longhand and then I said put them into index form, like we've just done, you would say it's 2 to the 5. Can everyone see the relationship between the 5 there, the 2 there, and the 3 there? You just add the 2 and the 3. So the base number, the 2, does not change. Nothing happens when you multiply that, okay? So the 2 remains as a 2, but what you do is you add your 2 indices. So the 2 and the 3 add together to give you 2 to the 5. So if we're looking at 8 cubed and 8 to the power 4 and you're multiplying them, if I put it out in longhand for you and then put it into index form, it would be 8 to the 7. But a lot quicker method, so this is a shortcut for doing all that nonsense, is to say I've got 8 to the power 3, I've got 8 to the power 4, my base number stays the same, they're both 8, so I'm allowed to do this. I can add my 3 and my 4 and get 7. Does that work for you? Yeah, is that a good process? When we have the same base number and we're multiplying 2 numbers with indices, we can add the indices. Exactly the same when we're doing division. When you have 2 numbers with the same base number with indices and you divide them, remember divisions very rarely look like this in maths, okay? What that's saying is 2 to the power 5, in other words 5 2's, being divided by 2 squared, these 2 cancel each other off and these 2 cancel each other off, leaving me in index form 2 to the power 3. Quick way of doing it is my base number doesn't change and I subtract the 2 from the 5 to give me my power of 3. Okay? Exactly the same for 8. 8 to the power 6 divided by 8 to the power 3. Instead of writing it all out and cancelling things down, all I need to do is say 8 is my base number, it doesn't change, and take away 3 from the 6 to get 8 to the power 3. Do not forget, you'll very rarely get given a question like that. It's more likely to look like that. Remember how we write divisions in maths? They're more likely to look like a fraction. So it would be 2 to the 5 over 2 squared. It's exactly the same thing in what it means, but it's more likely to appear like that in the exam. Okay? Rule number 3 then. Rule number 3 is when you raise a power to a power. What? I've got 2 squared and then I cube it. What's that saying in longhand? Well, it's saying I've got 2 squared and I'm multiplying it by 2 squared 3 times. We know from rule number 1, all I need to do is add my 2's. So 2, 2, 2 is 2 to the power 6. A quicker way of doing it is saying 2 is my base number and 2 times 3 gives me my 6. Okay? If we look at 8 to the power 4, 8 is my base number and 4 times 5 gives me 8 to the power 20, rather than writing it out in longhand and then tidying up using rule number 1. Okay? So they're the 3 first rules. They're the 3 most complicated rules, because the other ones are quite straightforward. Okay? So let's do an index match. So I just want you to look at this. Now, yesterday did card sort exercises matching HCS, and people say, oh, why are we doing this? We don't get them in the exam. You do. And the reason I've asked you the question in this way is this is the equivalent of what you were doing when you were matching cards yesterday. They have the questions on one side, the answer on the other side of the exam paper, and you draw a line between them to match them, which is essentially what you were doing with the cards yesterday. Okay? So I want you to look at the 3 questions, and in a second we're going to talk about where do we draw the line to answer the question. Let's go for it then. 2 to the 4 times 2 squared.
2 to the 6.
Everyone happy with that? So because we're multiplying them, we add our indices and we draw a line from there to there. And that's what it'll look like in the exam. That's the equivalent of a card match. 2 to the 4 divided by 2 squared,
2 to the 2.
which we call 2 squared.
Yeah.
And 2 to the 4 raised to the power of 2.
Oh.
2 to the 8. Everyone get that? That's rule number 1, 2 and 3. So don't worry about what all these letters are saying. What these letters are saying is that when I have the same base number, I add my indices when I'm multiplying. When I have the same base number and I divide, I take them away. And then finally, when I have a base number raised to another power, I just multiply them. Okay, that's what that's about. Don't forget, in maths, what we've just done for numbers also applies to variables, to letters. So if we talk about rule number 1 and letters, if I have a squared and I multiply it by a cubed, what's the result of that?
A.
Good, a to the power 5. Yeah, because my base number is still the same. It's the letter A. Okay. Rule number 2, I have b to the power 6 and I divide it by b squared. What's the outcome of that? B to the 4. Yeah, we take them away. B to the power 4. If you look at the third rule, and I have x squared raised to the power of 3, the answer is
X to 6.
good, x to the power 6. Yeah. So can you see how that works? So it doesn't have to be a number. They can, and probably will, give you variables to use. And we'll get some practice in a minute at the end on those. Indices, rule number 4. Okay? So this next set of rules, rules 4, 5 and 6, are just, this is the rule, end of. So anything with a power of 1 is itself. So 2 to the power of 1 is just 2. 8 to the power of 1 is just 8. A to the power 1, so if I say a to the power 1, it's just a. So anything to the power of 1 is just itself.
Is it the same then if it's a power of 0? Say if you had a to the power 0.
Next rule, stop racing ahead. That's rule number 5, you've gone one ahead, okay? Now, let's think about this for a second. Let's go back to rule number 2. And I've got a to the 5 divided by a to the 4. What's my answer?
A to the 1. Or a.
It's that eureka moment. Okay, this is how they try to trick you. They'll give you a to the 5 divided by a to the 4. 1, do you remember the rule? And if you write a to the 1, yes, you've kind of remembered the rule, but then you've forgotten rule number 4, because anything to a power of 1 is just itself, and they expect you to just write a. Yeah? Okay. Rule number 5. Anything to a power of 0 is the number 1. Okay? So, if you think about it, I've got 2 squared, and I divide it by 2 squared. What does that give me, according to rule number 2? 2 to the power of 0. So it makes sense. What's 2 squared? 4. And I divide it by 4. What's 4 divided by 4? 1. So that's why anything to the power of 0 is just the number 1. And then finally, 1 to any power is always 1. So if I had 1 squared, it means 1 times 1, which is 1. If I had 1 to the power of 5, it means 1 times 1 times 1, 5 times. 1 times 1 is 1, times 1 is 1, times 1 is... So 1 to any power is 1. So, if I have 1 to the 567, guess what my answer is?
1.
If I have 1 to the power a, guess what my answer is?
1.
You ain't quiet then. Yeah. So 1 to any power, any number a, is always 1. Yeah? So rules 4, 5 and 6, dead straightforward. You just need to remember something to the power of 1 is just itself, something to the power of 0 is 1, and 1 to any power is 1. You see what I mean? You don't have to juggle anything around, you just have to remember them. Okay? So there's your index match. So on the left hand side of the questions, what is 13 to the 1, 13 to the 0, 1 to the 13? And your answers are on the right hand side. So we're going to do a match. We're going to draw the lines across and match them. So 13 to the power 1 is 13. This is where people do get confused. 13 to the 0 is the number 1. And 1 to the power of 13 is 1. I did it that way. Right. That's just a summary in what we call variable form. All you need to remember in your own words, you don't have to write that down. You just need to remember it in your own way. Rule number 1, when the base number is the same and you're multiplying indices, you add the indices together. Rule number 2, when the base number is the same and you're dividing the numbers with indices, you take one indices away from the other. Rule number 3, when you have a base number to a power that is raised to another power, you multiply the indices. They're the 3 tricky ones. 4, 5 and 6 are anything to the power of 1 is itself, anything to the power of 0 is 1, and 1 to any power is always 1. Okay? So you don't have to write it down in that fancy algebra form, just try and remember it in your own way. So there are 6 rules you need to remember. Okay? Happy days? Okay. Let's start off with some easies, and then we'll do a couple of harder ones, and then that will just about be it. So the first one then. 10 to the 6 divided by 10 to the 4.
6 and 4. No, 10 and 4.
So you end up with 10 squared. Okay, k squared times k to the 5. Excellent. And p to the 4 times p to the 5 times p to the 6. Add them all together, p to the 15. One word on variables, okay? I've noticed it in the last couple of weeks when you've been doing formula and certain things. In mathematics, it's really important that you don't change the letter. And I mean, some people, if you have b squared times b cubed, are changing it to b to the 5. You can't change a lowercase into an uppercase in maths or physics or anything else because you're changing the meaning of what this is. So if they give you a little b, keep it as a little b. If you write big B's, you won't get the marks because that's a totally different number. That's the nth term stuff I gave you last week. A lot of things came back. Instead of having n 3n plus 2, people were changing it to 3n plus 2. That's not the n. This is the n, the little n, the nth term. Yeah? The little n for the sequence. Right, here's your next set of 3. So I've got a squared times a to the 4 divided by a cubed. I've got x to the a raised to the power of b, and I've got d to the 0. Okay, here we go. 8 squared times a to the 4 divided by a cubed. So what should I do first there? Yeah, add the 2 and the 4, so I end up with 8 to the 6 divided by 8 cubed, which gives me 8 to the 3. Because that's 8 to the 6 divided by 8 to the 3. The next one, x to the a to the power b. xab. Because you're meant to multiply this with this, so a times b in algebra is ab. We don't put the multiply sign in. Okay? And then finally, d to the 0 is the number 1. The last 2 that we will do in Unit 2, no, don't have to write them down, we'll talk about them. What's said to the 1? Yeah? Everyone happy? Anything with the power of 1 is just itself. And then 1 to the 237, number 1. Nobody wrote that one out for you, did they? Didn't have time, did you? Okay. that is the final objective of Unit 2. So, the objectives. Define and derive types of factors and multiples we did yesterday, along with squares, cubes and their roots. Today we talked about index notation, which is how you write them out in shorthand. So 2 to the 5 is 2 multiplied by itself 5 times. We then talked about the index laws. There are 6 of them. The first one's to do with multiplying indices, second dividing, the third raised to a power. The fourth is to the power 1, the fifth is to the power 0, and the sixth is 1 to any power.